Hello, you're welcome to Skyline Tutorials, where learning is made simplified and understanding is better. In Skyline, we set a pace in every exam that any student or candidate would encounter. Welcome to Skyline 90 Days to JAMB tutorial for every science student. Nonetheless, this tutorial sets a platform and it is a recommended tool for secondary and tertiary level students in preparation for any terminal or semester exams respectively. Ladies and gentlemen, let the journey begin. Welcome to day 1, Skyline 90 Days to JAMB Physics class. Today, we'll be doing an introduction to physics and to some people, reintroduction to physics. A lot of us may have difficulties in our foundation in physics. This class is set to make the pace to have a better understanding about your journey as regards physics preparation towards the JAMB examination. So today's class aims to cover the following: the overview and definition of physics, matter and energy, kinetic theory of matter, and the branches of physics. So let's begin. We have the definition and overview of physics. Physics generally talks about nature. The word physics is derived from the Greek word physis, which means nature. So physics studies natural phenomenon around the universe. Are you talking about the radiation from sunlight? If I throw my marker, what brings it down? Why is it that lightning, you get to the scene before the thunder is heard? All of these are questions that physics answers. Why is it better for me to use a machine than doing it myself? The functionality of a machine making to do work easier and applying lesser effort to overcome volume. Physics has a lot to play in our everyday to-day life. Physics generally studies natural phenomena. For simplified and more definitive definition, we define physics as a study of matter in relation to energy. So we have that physics studies matter and the interaction or relationship with energy. So let's look at these two terms that best define the word physics. Matter. Matter is popularly known to be defined as anything that has mass and occupies space. Anything that has mass and occupies space. For example, this marker. If I pile up thousands and thousands of markers in this room, realize that it can obstruct my movement. The implication is that it is occupying space, therefore it is matter. Take note of that. Another terminology that is considered in the study of physics is energy. Energy is defined as the ability or capacity to do work. Note that energy do not occupy space, energy do not have mass. For example, there are rays of light here, but irrespective of this radiation or rays of light, it cannot obstruct my movement. So you get to realize that energy is more like an antimatter. It does not have mass and it does not occupy space. So come to think of it, if you can think of anything right now, it will fall under either of these. Okay, so that is why by deductive reasoning we can say that physics studies the universe, because the universe generally will comprise of things that has mass and things that do not have mass. Other forms of energy may include sound. We have light, we have sound, we have heat energy or thermal energy, we have mechanical energy, we have nuclear energy, also known as atomic energy, and lots more. Okay, so back to this guy. We say that anything that has mass and occupies space is matter. Usually the word mass is often intertwined or confused with weight, but there is a good and clear disparity between these two terms. So let's look at the difference between mass and weight. Mass is simply the quantity of matter contained in a body. How much matter does a body has is its mass. Take note of that. So if this marker, for example, has more matter than this duster, you get to realize that this will have more mass than this. So note that mass is the quantity of matter contained in a body. On the other hand, weight is a force that acts on objects, pulling it downwards. It's a force, it's a force of pull that pulls objects downwards. Take note of that. For example, if I throw this marker and my duster, you realize something, that one would most likely fall first. And there are different factors that will determine which will fall first. The first factor that will determine which will fall first is the mass of either of it. And then we have air resistance. But another pivotal factor that will determine is gravity. So the mass and gravity of a body is what defines its weight. The mass and gravity of a body is what defines its weight. Like I said, weight is a force of pull. Take note of that. While mass, on the other hand, is the measure of matter contained in a body. Still on the subject matter of matter, let's look at the various states that this matter can take. So, an example could be ice. There is a freezed water. We have our liquefied water. And then we have steam. Steam is simply water that is in its gaseous state. So let's use these examples to talk about the three states of matter. Generally, there are three states of matter. The ice will occupy or is an example of the solid state of matter. The water is an example of the liquid state of matter. While the steam will be considered as the gaseous state of matter. So basically, these are the three states of matter that is known. Note that these various states of matter can change from one form to another. So let's take note of the different changes that matter can undergo. The first change we'll look at is a change from the solid to the liquid state. Note that matter can change from solid to liquid. If I take this ice out of a refrigerator, for example, due to a change in temperature, you get to realize that this ice will gradually be changed or converted into a liquefied form. That process is called melting. So a change of state from solid to liquid is called melting. Take note. A liquid state of matter can also be changed to a solid form. If I take this water that has been melted back to the refrigerator at a particular temperature, you get to realize that there is also a change of the state of matter back to the solid form. And that process is called freezing. Another change that matter can undergo is a change of state from liquid to gas. For example, when boiling water, either with your stove, yes, or your gas cylinder, using a kettle or a pot, you get to realize that over time, when the water gradually gets heated, you start seeing some vapor. Okay, so that vapor is simply what we call steam. It is simply the water that was in the pot or kettle, depending on the medium you use, that has been converted from liquid state to the gaseous state. Take note of that. And that process is called evaporation. Note that matter can also be converted from gaseous state to liquid state in a process called condensation. And then we have from solid to gas directly. If you have a camphor, for example, and you put it in your cupboard or your box, you get to realize that over time the camphor reduces in size, but your clothes don't get wet. What happens basically is the camphor that is directly changing state from the liquid to the gaseous state, and that process is called sublimation. And the last change that matter can undergo is a change of state from gas to solid in a process called deposition. Ladies and gentlemen, these are the various changes that matter can undergo. Still on the subject matter of matter, let's look at atoms, molecules, and ions. Still using my marker, you get to realize that in the breaking of any form of matter, there is a point where it can no longer be broken further. Yes, every matter gets to a point where it can no longer be broken further. There is the smallest part of this matter, and that part that is the smallest of a matter is what is referred to as atoms. Atoms are the smallest indivisible particles of a substance. Take note of that, or of any matter. These atoms are so small that they cannot exist on their own. What happens is that they come together to constitute what we call molecules. So atoms come together to constitute molecules. Take note of that. So matters are made up of atoms and molecules. For the different states of matter, solid, liquid, and gas, there are different ways that these molecules behave. Take note of that. There are different ways that these molecules behave. So let's look at the different states and the behavior or properties of these different states. Remember, we have said that these different states can change or vary from one form to another. Let's look at the properties of the various states of matter. The first we'll look at is a solid state. In every matter, there is a force that binds the molecules together. This marker, for example, is matter. So there is a force that binds the molecules of this marker together to make it behave the way it does. It has a strong force of cohesion, the cohesive force. The cohesive force is simply any force that binds molecules of the same kind together. Take note of that. In the different states of matter, there is generally what we call intermolecular forces. Intermolecular forces. These are simply forces that are within or between the molecules of matter. The word inter means between, like your secondary school inter-house sports, a sport between different houses. So inter means between or within. Molecular from the word molecules, and forces. So there are forces that are found between or within these molecules. And these forces is what aids the properties of all of the states of matter. The various characteristics we are going to give for these various states is owing to the degree of the kind or intensity of the forces that are found within the states. In a solid, you realize that a solid is packed up together because it has a strong force of cohesion. It likes itself so much, they are attracted to themselves. So solid particles are always packed up together. Also note that solid have fixed shape. A solid will also have fixed volume. A volume is simply talking about the quantities. Okay, so volume is basically talking about the quantity. So the quantity of solids are fixed. They also have fixed shape. They are tightly packed together. We can also deduce from these intermolecular forces the kind of energy that this exhibits. All of these states of matter exhibits kinetic energy. but the kinetic energy that they exhibit are varying to the different states of matter. Look at this. We have earlier stated that solids have strong forces that binds them together. The kinetic energy that are found within the molecules of a solid is lesser than the different states of matter. The reason is these molecules or these forces that bind the molecules together are tight and they are so strong that they do not allow the molecules of solid to move freely. Let's use a case study. Let's say for those of you who grew up with strict parents, let's consider our strict parents to be these forces, and let's consider our movements to be the kinetic energy. Note that kinetic energy is energy possessed by a body by virtue of movement. You get to realize that because of the strict parents you have, your movement is limited. Is that so? Yes. Because of the strict parents you have a tamed movement. You will not move anyhow. So that's what solids suffer from. They have strict parents, so they don't have the freedom to move anyhow. That is why their kinetic energy is far lesser, because their molecules are bounded together. I hope that is clear. So let's go over to the liquid state of matter. From my explanation in solid, you should get 1001 characteristics of liquid. So let's look at it. Liquids have fixed volume. Like I said, what volume simply means is quantity. So the quantities of liquid are always fixed. So if I have a liquid in this cup, let's say in this level, and then I put that liquid in this container, you get to realize that the same quantity that was here is what will get here. Still, because of the intermolecular forces found between the molecules, they do not have fixed shape. They are way loose than this. The next property of liquid we would consider is the forces. So they have weak intermolecular forces compared to solid. They have weak intermolecular forces compared to solid. Take note of that. And obviously, since their intermolecular forces are weaker than solid, they will have more kinetic energy than solid. Take note. It is more like an inverse proportionality. The higher the forces, the lesser the kinetic energy. The higher the forces, the lesser the kinetic energy. So that's it. Usually, all the properties of this different state of matter are explained in relation to another. So we say that liquids have intermolecular forces weaker than that of solid, but their kinetic energy is more than that of the solid. The next we have is gas. Characteristics of gas. Gas has the highest form of kinetic energy because they don't have strict parents. They move freely. Do you get? They move freely. They are not tamed. They move at random motion. So they have the highest kinetic energy. Take note. Another characteristic of gases is that they do not have fixed shape, unfixed shape. The next is that they have unfixed volume, except when in a confined container. They have unfixed volume. And then they have the weakest intermolecular forces. They have the weakest intermolecular forces. Like I said, the weaker the intermolecular forces, the more the kinetic energy. It is more of an inverse proportionality. So that's it about matter and the behavior of the different state of matter. We have also talked about the different changes that matter undergo. The next objective we would consider is the kinetic theory of matter. Ladies and gentlemen, the kinetic theory of matter and branches will be discussed in the next episode of our 90 Days to JAMB series. See you there.